Okay, made a pack of integration questions. Let me just make sure this is working. Pack number 1. What's the first question in this pack? I should have had this open. Blah 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 blah. Oh yeah, it's just x to the n. Okay, no, the first question is sine 4x. Okay, question 1. Your integral. You're gonna see this a lot. I'm gonna write I. Hopefully my mic isn't peaking. If it is, no, it's not. Okay. First integral. Integral of sine x dx. After practice, you'll be able to do this mentally, but I'll do it from scratch. Let's try differentiating. We'll try differentiating cos, negative cos, because we know sine integrates to negative cos. Like that's one of the standard results we have. So we can try differentiating negative cos, negative cos. That's an S. 4x. Which gives us negative sine, which is just sine 4x times the derivative of the inside. So this is just chain rule. So you should get 4 sine 4x. But we have this. So all we're going to do, I'm going to write I again. I want to put this into that form. So I'll just write this as 4. In fact, let me not skip steps. I have 4 sine 4x dx. But obviously, if I multiply by 4, I also have to divide by 4 because you can't just make numbers. So I'll put 1 over 4 here. You know what this is because we just differentiated and we got that. So we know that it gives us this. So we can plug it in straight away. And then I'll just move the minus outside. Done. Second question. I have no idea what the second question is. I also wrote this too high up. Second question is sec squared. Interesting. Okay. Your integral is sec squared, what, ax plus 5? Yeah, 8x plus 5 dx. We're going to use the same trick. Sec squared integrates to tan x, so we know we're going to get tan x somewhere. So we can try differentiating tan of 8x plus 5, which just gives us sec squared of 8x plus 5 times 8, because you differentiate the inside. There's a difference of 8, so I can rewrite this integral. You're going to have, I want it in this form, so I'll multiply by 8. Dx. And then also I have to divide by 8 because the original was just this. We know what this integrates to because we've just seen it. So you have 1 over 8 on the outside. Tan 8x plus 5. Let's see. I don't even need to do this, but I will anyways. And you're done. Next question. E to the 2x. This one's quite nice. E to the 2x dx. You know, differentiating e to the x always gives you e to the x. So in this case, we're going to try differentiating e to the 2x. And we guarantee to get 2e to the 2x. It's chain rule. You differentiate the e to the x, which just gives you the same e to the x. In this case, it's e to the 2x, which gives you 2e to the 2x. But with chain rule, you times by the inside as well, which is just 2 in this case. Compare this with this. So I multiply by 2 to get from here to here. So I have to divide by 2. So then I'm left with e to the 2x. That's an e. Because I know that integrates to that. It's just a reverse process. Plus c e to the 2x plus c. And we're done. Question 4. Oh, I ran out of room. Okay, next page. Yep. It's probably a more efficient way to do this. Next question is quite easy. 3 over x plus 1 dx. It's a terrible dx. This, at first, it takes a while to get used to, but whenever you have fractions, you always consider ln, or at least you'll try it mentally, because the difference in powers between here and here, this is x to the power 1, and then you have an invisible x to the power 0, which is just 1, right? So the power difference between here and here is 1. So we can try differentiating ln of a function that gives us this as a denominator. In that case, it would be ln of x plus 1, which gives us, actually I do it in one step, x plus 1 on the bottom, derivative of x plus 1 is just 1. We have 3 times that, so if we take out the 3, I just move the 3 to the outside. We know this integrates this, so you have 3 ln modulus this time, plus c modulus, because ln, I should put ln of x greater than 0. Actually, not ln of x is equal to 0. I should put if y equals ln x greater than 0. X is always greater than 0, because if x is less than 0, you get into the complex numbers world, which is not in the pure spec. Question 5 is quite simple if you recognize it. Hopefully you've been practicing trig. You've got the integral tan 4x sec 4x dx. First things first, tan x sec x integrates, I should probably write this down actually, integral tan x sec x dx is equal to x plus c. So if we were to have a 4x in here instead, we'll see what that differentiates to. So let's try differentiating. Whoops. Sec 4x, which is equal to chain rule. You're going to have your tan 4x sec 4x times the derivative of 4x, which is 4. Compare with this. Blah, blah, blah. So if I put this into this form, I would have to times by 4. And also divide it by 4. Cancel these two. And I'm left with 1 over 4 of this. Let's see. Perfect. Okay. Question 6. It's the integral of, I think it was 3 cosec squared. 9x. Okay. I won't do all of them, but it's just to get a general idea. This one cosec squared, it's also at the top of the page, I believe. It gives you minus cot x plus c. Differentiating cot x gives you minus cosec squared, so the minus just flips to the other side. In our case, we have, actually, I'll keep that on there. In our case, we have 3 times that and 9 in the brackets. So we can try, ignore the 3 for now, and we'll just try differentiating. Minus cot of 9x, which gives us positive cosec squared 9x with chain rule. Whoops, I wrote that too close. Times the 9 outside here. We have 3 of those instead of 9. So we're going to have to divide by 3. So, or rather times this by 3. You get the drill. So we'll get 9 cosec squared 9x. No plus, just dx. And we'll have 1 over 3 here. If it's hard to recognize, whoops. If it's hard to recognize, all I did, I times 3 by 3 and divided by 3. So 3 times 3 is 9, which gets us the 9 there. And 3 divided by, well, on the outside it divided by 3. So you got 1 over 3 here. We know what this is. This is just minus cot x, or minus cot 9x. So in the end, we get left with this, not cos, cot 9x plus c. Okay, I'll probably move on to a harder question. Actually, I'll do a few more. Question 7 is one that you get used to. I should probably do to the end to generalize it, but it's okay. Equals to the 4. Equals to the 4. Whoops. To the 4. If you were to integrate, actually, no, it's better to just try it immediately. Try. That does not look like it says try. There we go. This is something you tend to memorize. Differentiating x plus 1 to the power of 10. Because you know when you do chain rule, if I was to do d by dx of x plus 2 to the power of 3. You bring down the power, write the original function, minus 1 to the power, times differentiation of the inside, which is just 1 in our case. So that's like normal chain rule. Because we're doing the reverse of it, we're going to try 1 power up, see the coefficient it gives us, and divide by that. With practice, you also realize why that works, but as just a quick explanation, we're undoing the differentiation. So rather than getting the coefficient, we want to divide by the coefficient. Or I should have said, rather than multiplying by the coefficient, you want to divide by the coefficient that you get. Because it's the opposite of integration, you're going to get the opposite stuff, if that makes sense. So in our case, differentiating this gives you 10x plus 1 to the 9. If you don't know how to do that, revise differentiation. So I forgot to write I here. So we have an integral. We don't have 10 at the moment. I'm going to write 1 over 10 on the outside. 10 x plus 1 to the 9 dx. So our final answer should be, oh, it's 4. Whoopsies. I just realized. 4x to the 3. It works the same way though. So, yep. So you got 1 over 4, x plus 1 to the 3, plus plus c. Okay. Next question. What is it? X over x squared plus 2? Or x over x squared plus 1, sorry. Is that question 8? That's question 8. Okay. Our integral, I remembered. X over x squared plus 1 dx. This is another Lund case. The power difference between here and here is 1. Another thing to note about Lunds, be careful. It's not just the power difference I'm looking for. I'm looking for the fact that the derivative of this is very similar to that. In actual fact, the formula, I'll do a full generalized formula. K is just a constant. F of x dx is equal to, just so you don't get confused, f prime of x over f of x. I can't write. Okay, dx is equal to k ln f of x plus c. You can actually just memorize this, but I would recommend practicing and like realizing. It's like in this case, it's very quick because you see, oh, well, the derivative of x squared plus 1 is just 2x. So if I had a 2 on the top here, and I had divided by 2 on the outside to cancel that out, I've got the derivative of that and the original function. So x squared plus 1 derivative of that gives you 2x. So I can immediately just go 1 over 2 ln x squared plus 1 plus c. Because I just know that's how the derivative works for ln. If you didn't, here's an important piece of information. Ln of f of x, doing the derivative, I should really be using square brackets, is equal to f prime of x over f of x. That is just a fact. It's using chain rule. What's the next question? Question 9. That's quite a simple one. The scary thing here are the limits at the top of the bottom. I can't do a large integral. Okay. Pi over 4. Pi over 2. You have cot x cosec x dx. This is a standard result. So you're immediately able to go minus cosec x. Most people do this thing. I do the same thing. I just write it like this. I'm used to the way I see it written in lectures. It's the exact same thing, don't worry. It just means sub in this and sub in that and subtract them. So I got minus cosec pi over 2 plus, because you're going to do minus cosec, so it becomes plus cosec pi over 4. Cosec is just 1 over cot. So you got 1 over sine. Whoops. So you got 1 over sine pi over 2 plus 1 over sine pi over 4. These are things you tend to memorize. So this is negative 1 over pi over 2 just gives you 1. Negative 1 over 1, which is negative 1. Plus sine pi over 4 is just root 2 over 2. So then from there, root 2 over 2? Root 3? No, actually I don't know. Okay, let me think. You have 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2, which is just 2 over 2, which is just 1. Oh, okay, it's root 2 over 2. Interesting. So you're going to have 1 over root 2 over 2, which is just 2 over root 2. I'll do it in 2 steps. because this just goes up here, right? It's just fractions. You could leave it like that, or you could like simplify however you thought best. Question 10. This one's just a generic question, so I'll skip it. 11 is also quite generic. 12 is very generic, but I'll do it anyways. Because this one is just made to be mean and catch people off guard if they're not paying attention to what's inside the brackets. Okay, simplify the brackets, or simplify whatever's in the brackets, I should say. You got sine of 42x plus 41x, which is just 83x plus 40. And you know how to integrate this. You'll just get minus 1 over 83 cos. And you're done. Next question. 13. I'll go through 13. You have the integral x cubed over, I think I did 4x to the 4 plus 4 dx, I hope. Yeah, okay. This is another ln 1, the power difference, and like the derivative of 4x to the 4 plus 4 is 16x to the 3. We've got x to the 3, not 16x to the 3. I just recognize ln immediately. So all I'm going to do is make the top the derivative. So if I do the derivative of the bottom, 4x to the 4 plus 4, you'll get 16x to the 3 plus 0, which is what we have at the top. So I can immediately change this to ln. Plus c. Next question. Question 14. 2x e to the minus x squared. Famous integral actually, e to the minus x squared dx. Doesn't have an answer, so you're never going to get that question in A-level exam. The reason it doesn't have an answer, by the way, you know, differentiating e to the x, or e to the f of x. In fact, let me do e to the n, x to the n. You do the derivative of that, so you'll get x, nx to the n minus 1, e to the n, x to the n. So the power difference between this and this is just 1, right? But the power difference in our case here is 2, which is weirdly hard to spot. If I rewrite it as x to the 0, e to the minus x squared dx, you'll realize the difference is 2, which means reverse chain rule is not going to work because you have a difference of 2 and well, it's e to the x. Nothing is going to give you a difference of 2 when you differentiate. So you take special measures, like for instance, people put infinities here. I wrote root of 3. It's a good approximation though, root pi. But that's not in your spec. Don't worry about that. Your question is 2x e to the minus x squared dx, which we can do because the power difference here is 1 and 2, so that would be a power difference of 1. This is just integrating like normal. Differentiating e to the minus x squared gives us e to the I'll do it from scratch again so it's easier to recognize. E to the minus x squared gives us what is it? Minus 2x e to the minus x squared. That's normal differentiation. So I'm just going to write this as negatives on both sides. Dx. I don't know why I did that. There we go. This is just that, so it integrates to that. So we'll be left with a negative e to the x squared. Whoops, I forgot negative. Minus on the outside. This is just that. So we get left with this integral. Okay. Is question 15 difficult? Question 15 is not difficult. It just takes a little bit of thinking. I probably shouldn't write I for this one because it's very short. Integral is ln e to the minus x dx. Yep. Be careful with your graphs. Not graphs, functions. This is just simple algebra. Ln and e are opposites, right? So they cancel. The other way you can see it is if you do log laws, you take out this as a power. So you get left with minus x ln e, which is first of all just a constant. Like e is a number, ln of e is a number. The number happens to be 1, by the way, because log base e of e is just 1. So you get left with the integral of minus x dx, which is just equal to, what? Negative 1 over 2x squared plus c. Quite a simple question. Although it's annoying to spot unless you're paying attention to it, and most people tend to skip it. Next question, cosine. 12x plus 1 sine of 12, whoops, dx. Okay. First thing I'll try to do is simplify this. So cot x, because this isn't a standard result, it looks similar to some. It's not like cot x cosec, it's cot x sine. Cot x is sine x over cos x, or cot x, whoopsies, is cos x over sine x. So I can write this in terms of that. And then you've got the sine x here. Or the sine 12x rather. If you're wondering how I got this so quickly, cos x, which is just cos x, because this goes to the top, over sine x. So that's how I got it. You can also just remember it as 1 over tan x means everything's going to be flipped. Anyways, this cancels with that because they're the same. So we're left with integral of cos 12x plus 1 dx, which is 1 over 12 sine 12x plus 1 plus c. Yeah. Okay. Next question. 17 is okay for the most part. I will probably want the I here. Bear in mind, you don't need an I when you answer questions. I just prefer writing it so I know what I'm doing. X squared, x cubed, 3. Okay. All to the power of 3. For this question, you could reasonably expand this whole thing. Like, you don't have to use reverse chain rule. Although reverse chain rule in this case, if you practice, is faster. If you were to expand this, I'll just change this to x, and then I'll put the power afterwards. Actually, I could try now. X to the 9 plus 9x to the 6 times 3, 27x to the 6 plus, you would have x to the 3 times 27, no, 9. Nope, there's a 3 squared is 9, so it is 27. And then 3 cubed is 27. No, I probably made a mistake. Yeah, don't expand. You can, but like I wouldn't. It's reverse chain rule. The power difference between here and here is 1. And it also just like do the derivative of what is it? X cubed plus 3. That's a 3. It's a power of 4. If we try one power up, this just gives us 4 times 3x squared times the original integral with a power down. So we'll end up with 12x squared 3, whoops, x cubed plus 3 cubed. We have one of them, not 12 of them. We will rewrite this. So we do have 12 of them. And we know what this integrates to, which is this. Hence, we get an answer of, that's a 2 by the way. My 2's, fun fact, that's a z, that's a 2. I write z's like that. Anyways, you have x cubed plus 3 to the 4. Final answer. Next question, which is question 18, I believe. 18 is a good question, although it's quite a weird one that you probably wouldn't get in an exam because of the factorials, but everything else would be exam like. Whoops. And then you have plus 3 cosec. Is that sec? Yeah, it's sec. Whoops. Sec squared 2x plus 3 factorial cosec squared 4x dx. I've ended up doing all of them anyways, but it's okay. You can split into 2 integrals, so you have, let's deal with this part first. 4 factorial, if you didn't know, 4 times 3 times 2 times 1, that's 24. 3 factorial, 3 times 2 times 1, that's just 6. So I'm just going to immediately change this to numbers I know, because I don't want factorials or whatever in my answer. I just want numbers. 24 blah blah blah. This is a standard result, and it's just reverse chain rule. So instead of multiplying by 2, we're going to divide by 2. So we're going to end up with 24 2 10 2x plus, it's going to become a minus, you'll see why. Instead of multiplying by 4, we're going to divide by 4. 6 over 4 cot 4x plus c. And then you can just simplify. So we're left with 12 tan 2x plus 3 over 2 cot 4x plus c. We're done with that question. Question 19. Is there a question 20? There's a question 20. Question 19, e to the x over e to the x plus 1. This one is quite simple. If you've become experienced with Lunds, derivative of this, e to the x plus 1 is just e to the x. So you're left with e to the x plus 1 plus c. That's a c. Okay. And then finally, question 20, which probably actually threw anyone off if they were to see this in exam. Your integral is just a to the x dx. First of all, you need to know what a to the x dx, or a to the x differentiates to. Whoops. So let's start off in this side. Let's have y equals a to the x. You wouldn't actually do all of this working, but to explain. I want to differentiate this. So first, there's just a quick trick. I don't know what a to the x differentiates to, and I don't want to use the whole limit as h approaches 0 of like this. Like this is very long, and I'm also unlikely to get it by that point. So what I'm going to do, I'm going to use a very simple log trick, which you may know, which is e to the ln x is equal to x, because e and ln are inverses, so they cancel each other out. They're essentially opposites. So in our case, I'm just going to change this to e to the ln a of x, which is e, going to bring this power out, ln a. Ln a is just a constant. So y prime, or dy by dx. Differentiating e, you know how to differentiate e. You just bring the power down and then multiply by the original thing. So we would still have e to the ln a, and we'll be multiplying it by differentiating x ln a. Ln a is a constant, x is not. So we would just differentiate x, which is 1 ln a, and we could rewrite this as what it was before, which was this, because we did this. I don't know why I wrote the arrows like this. If we go from here to here again, and then from here back to a to the x. So if we have a to the x ln a as a derivative. Why is this important? Well, it's very important because we're trying to integrate a to the x. And we just differentiated and we showed that we get constant ln a. So in our case, we're going to take out ln a, multiply by ln a dx. And we know this just gives us a to the x because we've proven it, we differentiated. So our final result is going to be a to the x over ln a plus c. And that is the final question. Yay, I can't draw stars. Yay, okay.